Great. Well, thank you so much for waiting, and please welcome Noel. So Noel, if you did not know, is the author of several really amazing books. He's the author of Scala with Cats and more recently Functional Programming Strategies. And they're all free. You can find them online. He also runs Scala Bridge. So he's great help in getting a lot of new people into Scala and is an absolutely amazing teacher. I'm really keen to hear what he has to say on routing HTTP requests.
Thanks, Zainab. I feel I have a lot to live up to now after the introduction and after Anton's amazing talk. I'll do my best. Right, so this is a talk about HTTP routing or routing, depending on how you wish to pronounce it, which is probably something I think everyone would be familiar with. Let's just have a quick show of hands. Who's done web service stuff in Scala? Okay, pretty much everyone. Not sure if any hands that didn't go up. Okay, so this talk we're going to start by looking at what exactly we mean by request routing, and then look at this router that I've created and the design considerations and the approach to implementation I took with it, and then talk about some of the different approaches in the Scala world. We have quite a few different web frameworks, and compare implementations and maybe learn something about design of software. After this talk, I'd be interested to get your thoughts on what you think, whether you agree with my decisions or not. Let's get into it. So we'll start by saying, what is routing? And it's basically three parts to it. So the core of it is choosing the function which is going to handle an HTTP request. HTTP request comes into our server. We want to say, okay, what am I going to do with this request? And there are usually two sort of subparts of that. And the first part is, when you have this request, taking some stuff out of it. So maybe we're interested in parts of the path, say we're extracting like an ID from that path, or maybe we want to get the entity, the body of the request, which might be JSON. That's a very common thing. And then the other part of routing, which is not always part of all routing systems, is generating HTTP response from the result of whatever function we end up calling. Okay, so those are the three parts which I'm concerned with here. Let's take a look at some implementations that we have in different systems. So this is Play. Who's used Play? I have. Okay, almost everyone. So yeah, we've either worked at HMRC or we've done a lot of Scala. So in Play, the routing is in a separate file. It's in this little routes file, which is written in this DSL. It's not Scala, it's a little separate DSL. And what we can notice about this is that it doesn't have anything to say about the response here. So Play only handles the incoming bit, and then the generating the response is something that's written in your code, not in the actual routes itself. This is very similar to the Ruby on Rails routing, if anyone's ever looked at that. I imagine it was inspired by it. And we'll talk about this more later. Another example, HTTP4S, raw HTTP4S. Who's done that? Yeah, I've done that as well. Okay. In HTTP4S, there's no sort of routing library as such beyond these custom patterns that you have. So routing is effectively pattern matching. And I'd say arguably it doesn't really have anything to say about the response either. Just the pattern match for decomposing request, for pulling pieces out of it. Okay. Then we have Tapir. Anyone use Tapir? Okay, almost everyone's used Tapir as well. That's great. That's great. So everyone have opinions, I hope, about what's good and what doesn't work. Here's an example from Tapir. So what is interesting about Tapir is it specifies both what you do with the request coming in and how you generate the response. So here we're expecting the function that we choose, which I call the handler. It's going to take an int and it's going to produce a string and doesn't have to talk at all about HTTP details within that handler function. So the root in this case, the routing handles both parsing the request and assembling the response. And finally, we get to the library which I've implemented called crop. Who's used crop? Yay! Me, 2 hands. A few people who've been a Scala Bridge might have used it. And it looks like so. So it's from enough distance is similar to Tapir. We'll dive into the differences as we get into the talk. We see here we talk about how we handle the request. That's the request get bit, and we have the path there. We talk about how we handle the response, how we construct the response, and then we have this handler, which is a function from the integer we pull out of the path in the get request to the string that we produce. It produces a string which then goes into the response. So like tap here, this is handling both the input and output parts of the HTTP cycle. I'm going to need to grab my water bottle because I'm getting a bit croaky. Back in a sec. That was a very rookie mistake of me not to bring my water with me. Yeah. Jamie?
No.
Enjoying the talk so far?
Yeah, it's great.
Great. All right. Okay, and we're back. So let's talk a little bit more about crop, because that is the library I've created and the library we'll be talking about most of the time. So here's an example of a route that we've seen, and we can break this into the following parts. So first we have the request, which specifies how we handle an incoming request and what elements are we going to output from that, which is here just an integer. We have the response, which is saying how we generate an HTTP response from some input. And here that input is a string, which is due to the fact we have a text entity. And then we have the handler, which is this function from the inputs and the outputs. That's the business logic. All right. So the first thing we should notice about this is these are all values in our programming language, which means that we can be compositional. What do we mean by compositional? Well, it means that we can do the basically Lego thing. We can get small bits and we can build big bits by taking these small bits and sticking them together in different ways. So the example here, let's say we define the kind of root path for our API. All of our API lives under API/v1. And we can then say, well, the users bit of the API is that API/users. The products bit of the API is the API/products. So just a simple example of composition there. And we have another example then below, assembling the response. And the idea here is we are saying we have this not found page, which we want to use in probably a number of different routes, because lots of times you're saying not found. So we're going to name this part, and then we have a different response. Didn't want to put too much code on the slides here. We say is response okay or else not found. So another example of composition there, but this time on the output side. Okay. So what else can we do in crop? Well, one of the things we can do is reverse routing. And there are a couple of different ways of doing this. What we have an example of here is just generating a string. So I have a route. I can say, give me a path to this route, and I have to provide that parameter, the integer, which I pull out of the request. And this gives me a string that I can then embed in, say, HTML. So if we're generating a form, for example, we might want to have that link, or just any link in our website. If we're generating a website, we might want to put these links into it. So that's one form of reverse routing. There is another form, which is creating clients to call a route. And we can do the same thing. I've got to say at this point, it's not released, this code, but it's the same idea. I need to provide the parameter, the input. And this time, instead of just getting our string back, we're going to actually make a web request, and we get, like, say, an IO of a string. So representing that we're going to call this route, and then because this route generates a string, we can get that string back in our IO if it's a successful request. So two forms of reverse routing there. One for creating links to embed in HTML, another for actually calling the routes. This, I think, is actually very powerful. I've worked at a number of places where they didn't have any system like this. I know that other systems, Anton will no doubt want to tell us about one of them. Yes, you will. I know you will. But any time you're not generating your clients automatically from some kind of definition, I feel there's a lot of unnecessary work going on. It's definitely something people should do more of. All right. So that's an overview of what the crop routing system does and the main features we're aiming for. And now I want to talk a bit about the implementation. And two things in particular. What I'm calling variadic types, which is not really a term I've seen used anywhere. I just kind of made it up. But hopefully it'll be clear what I mean when we get into that. And then just the way that the builders are constructed, which is somewhat interesting, I feel. So let's talk about the type bits. So this is, I feel, one of the core problems you face in any routing library if you care about type safety, which every Scala library does. The fact is, there's a variable number of elements that you can pull out of a request. We have the example, first example, pulling out a single element, an int. Second example, we're pulling out a UUID and an int. So we get the question, how do we represent this in code? What are we going to do? If you're a relatively new Scala developer, you might think, well, we can just declare a whole bunch of different types. These are all paths. We'll just declare all these different variations of paths, which have, is there a comment there? Yeah. Okay. So we have a bunch of different paths that all have just a variable number of generic parameters, and that's not going to work. We just know if you're a more experienced Scala developer, you know implementationally, this won't work. So what can we do? Well, we can say, instead of having a number of type variables, or generic types, or whatever we want to call them, we can have a tuple, a single parameter, which is a tuple, because a tuple can have a variable number of elements, and each element can have a different type. But then how do you actually work with this? How does this work? All right. Well, in Scala 3, you can write this quite simply. You write something like the following path, where P, this type variable, is a subtype of tuple. Because in Scala 3, there's this common supertype for all tuples, which is tuple. And so we just need to have this type parameter, and we put this constraint on it that it has to be some specific instance of tuple. Like a tuple 1, tuple 2, tuple 3, so on. Okay, that's half of it. But then we need to do some tuple algebra at some point. As we get more elements out, we need to add them into the tuple we're constructing. Which means we're going to be changing the types as we go. So how does that work? And if you haven't used this in Scala 3, it's actually relatively simple. So what we have in Scala 3 is a bunch of tuple types, like tuple append, which allows to manipulate tuples. So let's take this method here, slash, where we're giving it a parameter. So we're saying there's a new parameter I want to extract from this path. That's a parameter of type B, where B is just whatever it is, int, string, UUID, whatever it may be. And what we say is that the result of this is going to be a new path where this tuple type is, take the existing tuple type B and append, sorry, the existing tuple type P and append B onto it. I probably should use different names that weren't so close in pronunciation. And this type is something that's built into Scala, standard library. And what it means is, as the example says, if P is integer and string and B is, say, double, then tuple append of P and B is the tuple int, string, and double. So it does what we want. It does this tuple type manipulation for us. And then when we get on the value level, manipulating the values, again, in Scala 3, we have methods that we can append values onto tuples. So it's quite simple to work with, just the way you'd work with any other collection in Scala. Those methods work. The implementation of these types, now, if you haven't seen these types before, they may be quite scary because they're doing computation at the type level, computation with types. But implementation is actually quite simple. It's using match types, which again are new to Scala 3. And you can look at it, and it's a very simple thing. It looks just like a pattern match, but it's matching on types instead, and doing the obvious kind of thing that you would do with a tuple, which you might do with a list, say, on the value level. So it's all, in Scala 3 at least, fairly standard stuff that we can do. Has anyone used this before, just out of curiosity? Yeah, I've used it. Anyone else? A few hands? Okay, not many. So it's something that's new. That's nice. Right. So the next little thing that we do in crop is working with these tuples again. So request is accumulating a tuple of values. But when we come to call a function, we don't want to have to write a function that accepts a tuple. That's kind of inconvenient to work with. We want a function that's just a normal function. If we have a tuple with n elements, we want a function that has n parameters. So we just have to do something to sort out this little mismatch of types, a tuple of n elements and a function of n parameters. And in crop, we have this little thing called tuple apply, which basically says, how do I apply a function of n parameters to a tuple of those n values? And so there's just a bunch of instances like this. And is this the nicest code ever written? No, it's not the nicest code to read, I'll tell you that for sure. But it's in the library, you don't have to work with it. We'll talk more later about the ergonomics of that. And hopefully at some point, I can replace it with something that's currently an experimental feature in Scala, this tupled function, and then you won't have this little obscure thing going on in the code. Just to read the code here, the main thing here is the tuple method, which says, give me a function, and I'll turn it into a function that accepts a tuple. So this is just the case of tuple one, the easiest case to write and to put on the screen. And so we have a function A to C, and we just get a function from a tuple one, and we pull out that element at index 0. So there's a lot of type stuff going on there that you may not be familiar with, but implementationally what it's doing is just getting a tuple and pulling out the elements and passing them to the function. So it's not that complicated when you get past all of the type stuff going on. All right. Now, let's talk about request type parameters. So far, I've been lying a little bit. I've said that a request just collects this tuple of values. But actually, there's lots of different tuples in a request. And why do we have this? That's a good question. So let's just go through what they are, and then we'll talk about the motivation for this. So we have 4 parameters, 4 type parameters here. The first one is all the values we extract from the path. Second one is the values we extract, type of the values we extract from the query parameters. Then we have the types of all the values we extract from the request, including the path and query. And then we have the type of the values we need to create a request, which may not be the same as the type of the values we extract from it. And we'll talk a little bit about these first 3, and the last one is really just a bit esoteric. It's not super important. Okay, so there's definitely some complexity here. It's not something that the user needs to see most of the time. Type inference has this, but let's say, why do we have this? Well, this is a requirement we get from the reverse routing. So when we do reverse routing, sometimes you want to create just the path. Like we have a form that has some query parameters as well. We need just the path as the action of the form to submit to, and the query parameters will come from the input elements in the form. So that's one type of reverse routing we have. Sometimes if we have query parameters, we want to add those onto the link as well. So that's a second related but slightly distinct type of reverse routing, adding the query parameters into the link that we generate into the string. And then the third type is when we're calling from a client, we need to provide everything. Everything that the root expects, including, say, headers or an entity and so on, like JSON, body, and that kind of thing. So different situations need different information, and we need to record that information in the types so we get everything as type safe. So this makes building the requests slightly complicated. And here I have a slightly more complicated example of building the requests. So the examples we've seen so far have just dealt with paths. And here we have a path, but we're also saying we require there to be a JSON header, saying we must be content type JSON. And then I'm expecting a body, an entity, which is JSON, and assuming the usual kind of JSON decoder stuff, JSON values and so on, of a user type. Kind of a silly request, but it's one that's simple and fits on a slide. Okay. So one thing that crop requires is that we specify these parts in the order that's shown here. You always have to have a method and a path. That's required for a root. Then you have optional query parameters. Then you have optional headers. Then you have optional entity. And it's in that order. So why? Why do we do that? Well, there are 2 reasons. One is just fixing the order makes it simpler to read, because you know when you read it's going to be the same thing. You don't have people writing things in different styles. And the other reason is it makes updating the type parameters easier, because you know exactly which of these parameters need to be adjusted and how they need to be adjusted. Otherwise, it's very complicated because you have to figure out, for example, we have that parameter which is everything that's extracted from the request. We need to figure out what's already been added to that, how do we need to adjust it, and so on. So it's much simpler if we have this fixed order, because then we just know how we update those parameters. Okay, so how do we implement that? So the implementation of request is a not quite algebraic data type. Just a quick check. Does algebraic data type mean things to people? To me? Yeah, okay, cool. All right, good. So by a not quite algebraic data type, what I mean is that these different instances have different methods on them. And when you call some of these methods, they'll transition between the types. So we have request method path when you've got just the method and path, which is where you start. And then if you add headers, you get into the request headers where you can add more headers. And if you add an entity, you get into request entity. So you can transition down here, but you can't go back up. So they form a very simple finite state machine. So effectively, the good old builder pattern or fluent interface that people might be familiar with from OO days, or basically a combinator library in functional programming speech, is a bit restricted. We have this slightly more advanced thing where we restrict certain transitions. You can only call certain methods in certain states. And implementationally, it looks something like the following. Now, there's a lot of type garbage up here on the screen. And you can ignore most of it. But what is important, what I want to highlight is this is request method path we're looking at, base class. So this is a request where we've only specified the method and the path, the two things that are required. And now we're adding a header with extract header. And what this returns is the request headers. So it makes that transition to a new type, which has a bunch of methods on it, and which allow you to do certain things, but not other things. And you can see when we construct this request headers, we're setting particular values in type parameters. And I didn't put all of the types in here because they're quite large, but all of these are extending request and they're setting those type parameters in request in different ways. I thought that was just a bit too much type stuff on the screen. Maybe it should go in there. Anyway, so that's how that works. So although these are all instances of request, they are distinct types as well, and they have these transitions encoded in the method calls between them, which allows us to constrain how the user constructs things and also make sure the types are constructed correctly. All right, so those are the main technical things in crop that I want to talk about in the routing library in crop. And now I want to talk a little bit about how we evaluate what is good. And I think this gets into something which I think Anton would agree with, which is writing code because of the joy of writing it. And yeah, I'll come back to this at the end, but I feel like this is something we don't consider enough. And in particular, when people talk about the qualities of code, there's a lot talking about sort of technical considerations, which are like the code itself, and not enough emphasis is placed on the process of actually using the code. What's it like to write? And the classic example of that back in the early days of Scala, Scala Z, Scala Z, whatever you want to call it, where they just had crazy symbolic method names, no documentation, and if you asked anyone for help, you were likely to just be insulted, basically. So I feel like we need to really foreground these process considerations. What's it like to write the code? But let's first talk about some of the technical considerations. So first thing, composition. Is routing built from reusable pieces? We talked about this right at the start. And play, not compositional. It's its own little DSL. There's no way of like naming and extracting bits that I know of. So no composition there. HTTP4S, again, not compositional, it's pattern matching. You can't make a pattern a value and then combine a pattern with another pattern unless you write more custom unapply methods, I guess. They're not really compositional. Tapir, however, is compositional, and crop compositional. Okay, so that's pretty easy. Well, reverse routing, we've talked about this a bit. Play, only for links, you can only do the bit where you make a call, like a string to a route. You can't do the client bit because the route doesn't store information about how to construct the response. So it doesn't have the information available, so you can't automatically construct a client that's going to parse that response because you don't know anything about it. HTTP4S, again, patterns are not values. You can't inspect them, you can't pull them apart, work out how to call them, how to make a link. So no reverse routing there. Tapir, you can do reverse routing, but only for constructing a client, not for constructing a link. And crop, we've both of these. All right, so that's that's the technical aspects, I think, what people normally talk about when they talk about code quality. But what I really want to talk about is some of these process considerations because they're not so obvious in the design of code. And I think this is interesting. I think it's useful. So most of the time, most code is written by humans. Anyone here not writing the majority of their code these days? Anyone living the vibe, dream? Not me. I'm still writing most of my code by hand, still about 99% organic. So this is like, what's it like to use library? Can we get a junior developer to use a library, and will they actually be able to be productive, or are they going to get hopelessly bamboozled by it? It's a much more subjective area. Interested to hear your thoughts after this. So one of the criteria I use is what I call dot-driven development, which is basically, can I press the dot key on my keyboard, and can I get a useful list of completions, and can I just follow these completions to get the job done? We have to face the facts as library authors. We're trying to make people's lives easier, but the ideal library is something that just gets out of the way and lets people get on with their real problem, which is whatever the business requirements are, or their personal fun requirements. Nobody's writing a web service for the joy of just doing web stuff. They want to achieve something, which is the bits that are not the actual web stuff. That's the important bit. So, can I press dot and just stuff happens? Play, well, no, it's this external DSL. Maybe if somebody's prepared to spend an inordinate amount of effort, the IDE knows about it. Like, for example, I don't know if IntelliJ knows about the play routing DSL. I don't think it does, but I could be wrong. It does. Okay. I don't use IntelliJ, so my editor does not know about it. So maybe the IDE knows about it, maybe it doesn't. HTTP4S. Pattern matching, it's nice for solving the problem of how do I get these values out, because patterns can introduce names. That's great, but you don't get completions here. So you have to go and look at the documentation. You can't just follow the completions to get the job done. Tapir. Now, there's one decision they made here which I disagree with, and that is all of these little combinators like path and string body, these are just functions you import from some global object, like in the package object. So when you're doing whatever the import is, you get these into your sort of global namespace, which means that the completion doesn't work as well because you just have your top level namespace just full of stuff. And there's a lot of stuff there by default in Scala, so they're quite hard to find. So I don't think this is the best design from the point of view of dot-driven development, from the point of helping people write the code. In comparison, on crop, the design is explicit that if you want like a request, you type in request, you press dot, you get completions, which are things that construct requests. So there's something of a philosophical difference here from Tapir, which is quite close otherwise to crop. The idea is you can follow the types. So let's say you type root, and then you'll see that the parameters have type request and response. To create a request, you can type request, and you can press dot and get the completions. And then you'll see that it needs a path. You can type path, you can press dot, and you get completion to follow those. So it makes the code a bit more verbose, but I believe it makes it easier to write and perhaps easier to read as well. So overall, I feel like crop is a little bit more structured than Tapir. One of the other differences is the way that we store these type parameters that have separate type parameters for just the path and query, and then everything, and the structure with which we construct them, which allows for the more flexible reverse routing. All right. Now let's talk about error handling. It's very common to have libraries which are lovely and type safe and do all this, have this fun stuff, but when they go wrong, you get some inscrutable error, like implicit not found. Try to find this thing you've never heard of and have no knowledge of, and everything's gone wrong. So how does it work in the error cases? So one thing which is part of the routing library is we have a development mode in crop, and in development mode, when you get a not found, you actually get a page displayed to you saying, could not find a route for the following request, and it shows you the request, and we show you the routes that are available. And of the libraries I know, only Play has an equivalent as far as I'm aware. And in fact, Play has been quite an inspiration to me because I feel they did a lot of work on this developer process. They just fell a bit behind in terms of the actual, like the technical considerations. Another thing is just avoiding givens, implicits where they don't really need to be. So for example, you want to pull an integer out of a path, you have a parameter .int in crop. It's just a normal value. It just works the way normal values do. You want to do the same in Tapir. Well, you have an implicit value here under the hood, which is doing some decoding. Effectively the same when things work, but when they don't work, it's a very different experience. So when crop doesn't work, it's just because you're calling a method or a value that doesn't exist. That's a very straightforward thing to fix. When it doesn't work in the case of Tapir, you're going to get some implicit not found type of error. And if you're a junior developer, you're then just lost. You don't know what's going on. You have to, where is this thing? What do I need to import? How do I have, sometimes, people have multiple imports which are colliding, and it's just much more difficult to debug. And I don't think in this case it gives any usability benefit, really. Another thing we can do is add implicit not found annotations. So an example of that is in the tuple apply thing I showed earlier, which is converting from the tuple to the n-ary function, tuple of n elements to a function of n arguments. If somebody makes a mistake there, you don't want them to see this tuple apply not found. Again, it's saying like, something you don't know at all about is not found and you don't know how to fix it. So you can add an implicit not found annotation, which has a custom error message saying, you tried to call this function with these arguments, with the tuple with these, and they don't match up. There's some suggestions to go and fix it. So just putting those little details in makes life a lot easier. And another thing is just Scala 3. So these semi-meta programming tricks that I'm using are a lot easier in Scala 3. Most of them are built in. If you do this in Scala 2, you'd have to use shapeless. If you use shapeless, you're then into a new world of obscurity. Bad error messages, bad documentation, and so on. So if you haven't tried Scala 3, it's just trying to get your company to shift over to it if you can. Or just do it in your own personal projects, and it just makes this type of thing so much easier and so much more accessible. I really like it. All right, so that's all I want to talk about here. I just want to talk a bit about the philosophy, though, because I feel this is important. I feel something that you really need to get back to in the Scala world. And I think Anton, mad scientist Anton, is a big proponent of this, which is just making stuff that's a pleasure to use. I find too many Scala libraries I use are just annoying. They may be well designed from certain technical considerations, but they don't bring a huge amount of joy. Trying to track down imports, for example. Anton talked about single imports. Trying to figure out where the thing I want is, which package I need to import, is not at all exciting. There's no joy there. I want to get back to a world where people excited to use Scala. People are like, I want to write my personal projects in Scala because it's so much fun to use. It's so good. And I think we do have a fantastic language here. I think we've got a fantastic runtimes, I should say, because we have multiple of them. I feel like Scala is a really powerful language and can be a really fun language to use. But I feel like the community has gone too far in terms of writing code which is good on technical considerations but fails to address the human side of programming. I don't want to name names here, but I'm sure you all know some examples. Hopefully, I feel like there's a surge in new libraries coming up which are just more productive and get things done. I think Antil stuff is fantastic. I love it. I love Q4S. You mentioned Magnum as well, a database library, which again is just very productive, very nice. Just allows you to do basic things really, really easily. I'm trying to do the same here with Crop for web frameworks. Anyway, I get there. I'd love to get your feedback on it if you do take a look. And yeah, that's all I have to say. Thanks for your attention. If you want to check it out, that's the URL. That's my email address. And also, I'd love taking questions if you have them now.
Thank you so much. Okay, we've got quite a few. I think you guys have spoken a lot already.
I know. Core library, I have 2 questions. So first one is, I might have missed it, but I don't really see a type parameter for the body of the request. Is that?
Yep.
And second question is, what are your kind of grand plans, or, you know, if you have infinite time, what would you implement with?
Infinite time and infinite resources. Okay, so the body just gets lumped into this parameter, I, all of the values. So it includes like tuples for the, so if I remember correctly, it's the tuple of tuples. Has a tuple of stuff you collect, you get it from the path and the query, and headers, and then the entity. And so it's in there. It's not separate because there's no need to have it separately that I can see. And then what would I do with resources? Where do I want the project to go? Okay, so first thing is, where we are at the moment is you can write stuff in crop. There are some missing features, but it's usable. And I feel like, I didn't talk about the larger project as a whole, but I feel like it's got a good story for getting started easily and that kind of stuff. Where I want to go to, I think there are 2 models for web development, which I should say there's one thing I want to reinvigorate. Instead of just writing web services, I want people to write web applications, websites, the whole thing. Just write it in Scala. Why not? Stop writing just, you know, the web service, the API. And there are 2 models there. So one model is the server-driven model, where you basically treat the HTML as like a fairly dumb layer, and you send diffs to it. You say, delete this node, insert this node at this location, this kind of thing. And you have a little bit of JavaScript added in there to do animations and transitions and so on. And there are a few different libraries for that. One of them is probably the best known, HTMX, but there are others as well. Alpine.js is another one, and so forth. So that's one model as well that it's quite easy to support, and there's a little bit of preliminary support there already. The other model that I'm personally more excited about is when you program a lot of stuff on the client. Why am I more excited about that? I'm more excited about it because I'm excited by the idea of local first applications. And this, I think, gets into what Anton is saying about building applications to suit your own personal needs, just like hobby stuff, or just things that, like, rather than having all of our personal data stolen by large corporations, I want a world where we write applications which just live on our phone, say, and we could share it with friends. Maybe we just share like a sort of cloud storage folder or something like that, like a Google Drive folder or a Dropbox folder, and that has all the information we share with each other, and we can use that to sync. So getting away from having to store stuff in servers, getting away from centralized storage, putting control back to us, all of us, And there I feel Scala has a great story because we have the server side, we have the compile technology to compile into JS and WASM. We have all the types and good stuff to just make it seamless to send information across boundaries, to implement CRDT things as well, which are kind of fairly mathematical stuff. So I feel like we could have a really interesting platform there. Developing it is a lot of work, but it could be fun. So if I get the time, hopefully I'm going to be taking a crack at that. All right, great question.
Thank you very much. Any more questions?
Jamie's got one.
Jamie has one, but he can ask us, and we'll get a few more.
I have 2 points and a question. The
Okay,
first is
more of a comment than a question.
A, documentation, make it great. B,
Right.
I'm a massive proponent of good documentation.
Okay.
B, I am now effectively a Scala full stack developer. That's my moonlighting job now.
Okay.
And one thing that bugs me is Scala first libraries or JVM first libraries often don't care about bundle size. So big problem with Tapir, and I've fixed one of these, is like you pull in Tapir, your bundle size just goes whoop,
Okay.
especially as it pulls in a lot of transitive stuff. So
Right.
like there's a point of like being mindful that, say, your parameter int stuff are methods, not values, because as soon as you attach a value to an object, that's it. It's in the bundle. It ain't going anywhere. So if you really want this to be something for web development as well, there's so many annoying considerations to make.
Right.
So my question was, you had this. You described it as like the functional builder kind of thing. And that means, I guess you're saying you can specify your path parameters and then your headers and so on.
Yep.
You can't interleave them. Am I right?
You don't need to.
You can't interleave them. You can't sort of, because you're saying you want to restrict.
Yeah, they're specified in a certain order.
So does that damage compositionality a little bit because you can't sort of factor out common template endpoints and say, well, I actually just want to attach a header to this already completed thing, or.
Okay. So 2 comments and a question. We're going to treat them all like questions and answer all of them. Okay. So first, I agree with you with that documentation. I didn't bring that up because all of the things I was comparing to have documentation. Do they all have good documentation? I don't know. That's kind of in the eye of the beholder. I definitely find some of their documentation hard to get around, some of the other things. But then I don't know if that's just I'm used to like the documentation for crop that I wrote. I find very easy to get around. Maybe it's just because I wrote it. Not sure. But I definitely find all of the others that I mentioned, the play documentation, HTTP4S documentation, and the Tapir documentation, quite awkward to get around. Bundle size you mentioned, I guess you were talking about bundle size that would generate JavaScript then, right? Yeah, that's not something I know really much of anything about. It'd be interesting to read more about that. I don't know what the rules are there. So that could be interesting to see. Yeah, I guess so. I haven't looked at bundle size at all. And because it builds on top of HTTP4S, it's probably quite big, I imagine. And then compositionality. Does it hurt compositionality? Yeah, I mean, so the first thing is you can always define little functions which take in a request of whichever subtype of request you're interested in and add the stuff onto it. But that's not very convenient, I agree. So yeah, you can't like create a request without a path and a method, for example, but with a header. Is that a problem? It hasn't been a problem in what I've done so far, but yeah, maybe it could be in the future. I think it's a trade-off there. I imagine this be something I'll be happy to revisit if experience shows that this is a big problem. My stuff has been very simple and just like you declare a little API and add stuff on, and that all works well. And normally I'm not worrying too much about headers because those are normally added anyway by the entity. As soon as you say you have a JSON entity, you're basically setting the content type. So not a big problem. But yeah, it does restrict composition. Right, is there another question? I saw another hand going up. But more hands. They're going crazy. I think the. Okay.
Thank you. So the tuple stuff that you mentioned is probably not too familiar to most people here. Am I correct in thinking that essentially deprecates shapeless?
Right. So I'll just repeat the question because I'm not sure if the mic was picking up or not. It's essentially, is the tuple stuff deprecating shapeless? Shapeless still exists for Scala 3, but I think the majority of uses of shapeless are deprecated. So one is the H list in shapeless, which is now replaced by built-in tuple types and the types and the methods on tuple. So that serves the role of the heterogeneous list, H list, in shapeless. And the other thing is the generic derivation of type class instances, which you can. The Scala 3 documentation says we suggest you use a different language, different library to do this, but here's how to do it just using Scala 3. And I've always just done it using Scala 3. I've never found it to be a real problem. So should you reach for shapeless there? Maybe if you're doing something quite complicated, but I haven't needed to in my. And I feel those are the main things that people use shapeless for, although there's a huge bunch of tricks in there. That's what I've used. So I guess the answer is yes.
I think to follow on that, actually, the shapeless 3 code is very, very small. So if you go and have a look just at the shapeless 3 code base, it's all built on top of this stuff, which and so now it's very tiny.
Right.
So I wanted to ask about the experience with match types in from the ID perspective, like ID suggestions. So I have myself started experimenting with them only recently, and often the match type reduces from the compiler perspective, but I guess it's the presentation compiler that doesn't give me, it shows me, like it would be in your case, I don't know, path query of tuple.append instead of the reduced tuple. But I don't know what how it works for you, but that would be the equivalent of my experience with them today.
That's a good question. And I've got to admit that I don't write out the types in my use of crop when I'm creating routes. I don't write out the types for them because they are kind of long and inconvenient. And the type inference works fine for me. So I don't ever actually see these match types much. That's not a concern I've had. If you use IntelliJ, your experience is probably different to mine because I use Meta. Okay, right.
Yeah, if I would like hover over variable.
Right.
In some cases, not always.
Yeah. There is one issue with the tuple types. So the match types, they have an order of execution, and people want their things to be more like Prolog, where you just kind of execute in any order that gets you to an answer. That's not what match types do. I'll give you an example. So the tuple concatenation is defined so that it looks at if you concatenate a left and a right tuple, it looks first at the left tuple and does all the concatenation, and then looks at the right tuple. So if the left tuple is an empty tuple, it's going to go, okay, cool, we just get the right tuple. But if the left tuple is not an empty tuple, but maybe something we're not sure what it is, just like, a generic tuple type, then we don't get that produced, even if the right is an empty tuple. Whereas you can define the match type. If you in the definition, you can say, look at the left and the right, look at the right and the left, otherwise do combination. And then they're not sort of defined in that way, and because they have this order of execution type of thing, then they don't reduce where they could actually reduce. So I've noticed that, but I haven't noticed in the use of crop having problems because I'm very familiar with the framework and I don't notice these problems, perhaps.
To add to that, if you have problems with tooling and you use Metals and VS Code, the team at VertisLab, who are responsible for developing that, have open source tooling sprees once a month. So you can actually go and contribute to the tooling yourself. They will walk through your bug reports. You can go and solve the problems with them, which is very fun. Any other questions? Cool.
So I think this is a failure of my reading comprehension. Earlier, when you were talking about the generating like a client from your roots, was that a client in terms of you've got roots and you're calling them like a function and getting a result back? Or is that a client in the sense that you're entering some data and getting a HTTP request?
It's a client in that you're calling a route and getting a result back. Yeah, so say it's work in progress. The idea is to support it in the web browser, so you can just make direct calls to your API from your your application's client, or you could do it from server to server as well, with different implementations available there.
Yeah, so under the HUD, that's sending HTTP request.
Yeah.
Okay.
Okay. Well, thank you very much.
Thank you.